array of structures. Okay class, such as array of integer, array of characters, array of float, array of double. There is also array of structures. Okay class, in array of structures, number of structure variables are stored in array. Problem: write a program in C to input the details of 100 employee and print the details of those employees who have salary greater than 10,000 rupees per month. Okay class, so here is a void main struct employee here char name of employee. Okay class, int age of employee, float salary, employee ID. This structure is new data type is created here. Now struct employee, here is a variable a is a variable. Now we make it array of 100 elements. Okay class, array of 100 elements. Now for I equal to 0, I is less than r equal to I is less than 100, I plus plus scanf %s for name, %d for employee ID, %f for employee salary. Here ampersand a of I dot name comma ampersand a of I dot ID comma ampersand a of I dot salary. Okay, details of 100 employee are inputted here through the scanner. Okay, now for I equal to 0, I is less than or equal to 100, I plus plus. Here if A of I dot salary greater than or equal to 10,000, printf %s for name, %d for employee ID, %f for salary, ampersand A of I, sorry, not ampersand, A of I dot name, comma, A of I dot ID, comma, A of I dot salary this for loop is closed here and main is closed here. Class, this is a problem. Problem is write a program in C to input the details of 100 employee, and detail contains employee name, employee ID, employee salary. Okay, and print details of those employee who have salary 10,000 per month. Once again class, write a program in C to input the details of 100 employee, and details contain employee name, employee ID and employee salary, and print the details of those employee who have salary greater than 10,000 per month. Okay class, so this is a problem, and for that problem there is a program using structure. Class, here struct employee A of 100. Here A is a structure variable, but there are 100 structure variables. You can write it A of 100, you can write it A of 0. A of 0 is a first structure variable, A of 1 is a second structure variable, A of 2 is a third structure variable, dot dot, A of 99 is a 100th structure variable. So class, there are 100 structure variables. We make it array of structures. Here we make it array of structures. Basically A of 100 is expand here, A of 0, A of 1, A of 2, A of 3, A of 4, dot dot, A of 99. There are 100 structure variables. Okay class, these are the structure variables here. So we make structure variable in array, we make array of structure variables. Okay, so A of 100 here, so the array of structure variables, array of structures. Okay class, so here we know that by default scope of for is single line, so there is no need to mention curly bracket open, curly bracket close. By default printf is scope of printf is also single line, so there is no need to for single line there is no need to write the curly bracket open and curly bracket close, but here there are two statements, statement 1 and statement 2. So there is a need to write the curly bracket open and curly bracket close. But class here, if there is no curly bracket open and curly bracket close, you can write here curly bracket open, curly bracket close also. But scope of if is single line, that's why this printf is within scope of if. Here this is kind of is within scope of this for loop, because scope of for loop, scope of all loops, scope of if else has single line has single line. So here class program execution start from main struct employee char name of 30, we make it array so that you can input multi-word name of employee, int employee id, float salary employee salary, here semicolon. Class, this is the name of structure, employee's name of structure, this is the structure members or structure elements. Okay class, this whole things from here to here, this whole things is a new data type, because structure is a user defined data type. Here user define the data type from here to here. Okay, once you have defined the data type, then copy this line from here to here and write something. This is the variable. Okay, there are 100 variables here, there are 100 structure variables. Copy this line struct employee here, struct employee here, this is the data type and this is the variable, but this structure variable is array of 100 elements, so there are 100 structure variables. Okay, a of 0, a of 1, a of 2, a of 3, there are 100 structure variables, so it is array of variables, or you can say array of structures. Okay class, now from I equal to 0, I is less than 100, I plus plus, scan of percent s input the name, percent d input the id, percent f input the salary. Okay, m% because it is scan of, so we use m% a of I dot name will be input here, m% a of I dot id will be input here, m% a of I dot salary will be input here. Class, B access the structure members or structure elements by the variable, structure variable. This is the structure variable, this is the structure data type, and this is how structure data type is, So when we access the member of structures or elements of structures by the variable, dot operator and name of this. Okay, so here is a variable, dot operator and name of this, variable, dot operator, name of this variable, this is the variable, structure variable, this is the dot operator, and this is the structure member. Okay class, in this way we access the structure members or structure elements. These are the structure members or structure elements. So class, in this way we input the details of 100 employee. Okay, when I have value 0 is less than 100, yes, here a of 0 dot name, first employee's name is entered here, a of 0 dot id, first employee id is inputted here, a of 0, first time I have value 0, a of 0 dot salary, first employee salary are inputted here. So class, in this way when I becomes 1 is less than 100, yes, again all three details are inputted for the employee, for the second employee. Okay, in this way we input the 100 details of 100 employee. Now we are going to print for, if you do not write if, then 100 employees details will be printed here. If you remove this statement, if statement, if you remove this if statement, then this printer print the details of 100 employee. What you have input here is printed, but there are some constants. Okay, print the details of 100 employee who have salary greater than 10,000. So here is a checkpoint. So if a of I dot salary greater than or equal to 10,000, only those employee details will be printed here. Okay, so this for loop is closed here, and this main is closed here. Okay class, this is the array of structures or array of variables. This is the array of variables, array of structure variables. That's why this is called array of structure element, array of structures. Sure. Nested structure. Struct address, char city of 30, okay, int pin code, class, and long phone. Struct employee, struct employee. Here is a char name of employee basically, and struct address A. There are two structure, there are two data types. There are two structured data types here. One is this and second one is this. There are two structured data type. Okay. Here struct employee I is a variable of this structure type, and we have assigned it value. Amit, name of Amit, again city, Gorakhpur, pin code and phone number. Okay. Printf %s for name, %s for city, %d for pin code, %ld for phone number. Okay, here I dot name, comma, I dot a dot city, comma, I dot a dot pin code, here I dot a dot phone. Main is closed here. Class, this is the nested structure within another structure. Okay class, nested structure is one structure within another structure. Here class, there are two structure data type. One is this, and second one is this. There are two structure data type here. One structure data type is this, another structure data type is this, and we declare the variable I of this structure data type, structure data type, and we initialize, okay, and we printed them. Class, here program execution start from main, control comes to this line. Here the struct keyword, address is a name of structure. These three things are the element of structure, are members of structure, and this whole things from here to here is a structure data type, or you can say new data type, or it is a user defined data type. Same thing is here. Here is another structure keyword, structure name, structure members, or you can say structure elements, both. Okay, so here is a one data type, structure data type. Here is another structure data type. We make variable of this structure. We copy this line, struct employee, this is the data type from here to here of this structure. Struct employee is a data type of this structure, space I is a variable, of this data type. This is the data type, this is the variable, and this is the constant. Okay, so I is a structure data, I is a variable of structure of this. Okay, and B assign the corresponding constant or value. So class, since I is the structure variable of this structure, so first is name, so we write here Amit, and second one is a and this A is a variable of this data type, and this A is a variable of this data type, and this structure data type has three things. Okay, so we write here Gorakhpur city, pin code this, and phone number this. All four value assigned to I. Okay, we can access this from here. Class, this is the data type. This is basically whole line is a structure member or structure element, but when we see in detail, this is the data type, this is the variable. Okay, this is the data type and this is the variable, or you can say array, and here is also this is the data type and this is the variable. This data type is this, and this is the variable of this data type. So we can so it is declared within this structure, so we can access this. Once again, this is the structure member, this is the also structure member. Class, this is the data type, this is the array, and from here this is the data type and this is the variable. Okay, this data type is basically a structure, this structure, and B declare it within this structure. So B can access of these things by the variable of this structure. So here struct employee is a data type of this structure, struct employee is a data type of this structure, and I is a variable of this data type or this structure. Okay, so here B are going to initialize. Okay, first is name, so this is Amit, second is a, and this A is a variable of this data type, and this data type is basically this. So it has city, pin code, phone number. So city, pin code, phone number. We initialize this. Now we can print these values. Percentage for name, percentage for city, %D for pin code, %LD for phone number. So I dot name, we can access the structure elements by variable name, dot operator, and name of structure elements. Okay, so I dot name, this will be accessed here, this will be accessed here. I dot A dot city class here, basically city is a part of this structure, and B are using here, B are declaring here. So B can go here from I is a structure variable of this I dot structure variable of this dot structure elements. So I dot A dot city, basically city is a part of this, not this structure. That's why we have to go through structure variable of this. So structure variable of this dot structure variable of this dot its member name. In this way we access all elements of this structure in this. Okay, and we print Amit, Gorakhpur, and this will be printed here. Okay class, so in this way you can see this structure is called in this structure. Okay, and we use this whole things by declaring the structure variable of this and initialize here, all things are initialized and printed below. One more problem, that is a struct employee. Here is a char A of 30, and here int id, here float salary, okay class, this is closed, semicolon, and you write here void main and declare the variable of this here, struct employee E. E is a variable of this data type. Okay, and here you write Amit ID is a salary is a 10,000 suppose, class printf %s for name, %d for id, %f for salary. So here e dot a, here e dot id, here e dot salary. Class, here we declare the structure above the main, before the main. That's why it becomes global and it is visible for any function. Okay, it is visible for all function in the program, because we declare the structure, we define the new data type, structure data type before the main. That's why it becomes the global. Now this structure is visible for all function in the program. So main is a function. This will be this can be used, this can be visible also in the main. Okay, so here we declare the data type struct employee. We copy this in the main. Struct employee is a variable of this structure, or you can say this data type. This is the data type, this is the variable, this is the constant, and we print them. E dot a, e dot id, e dot salary. We access these elements, and these structure elements has these values. So we can print here. In this way you can see structure can be declared before the main, so that it can visible for all functions in the program. So this is also visible in the main. That's why we use struct employee e equal to this and print this. Okay class? Here we declare before the main. Structure is declared before the main, so it becomes global. Now it is visible for all function in the program. Main is a function, so it can be also visible from this main function. Program execution start from main. Program execution start from main. Okay class? So struct employee e equal to this. We can use, no error will be here, because this is the visible here. So we can use this directly. %s for printing a, that is the name of employee. %d to print id, that is the id of employee. %f to print the salary, that is the salary of employee. And e dot a, e dot, this is the variable, this is the dot operator, and this is the id, the structure member. So e dot a, e dot id, e dot salary. In this way we access this. Okay, and value of these structure elements are this. So printf print Amit 307 and 10,000. Structure and function. Class, topic is structure and function. Here we pass elements of structure to the function and variable of structure to the function. Okay class? Here there are 4 user defined function. One is a main is a user defined function from here to here. Second one is a function a from here to here, and third one is a function b from here to here, and fourth one is a function c is the name of function, okay, from here to here. So there are total 4 user defined function: main, function a, function b, function c. Class, here all function are defined after the main. All function defined after the main. Basically function a function B, function C are defined after the main function. Basically, those line of code is after this main function. So there is no space, that's why B right here. Okay, so function A, void B, this is the function, function B and function C. All three functions are defined after the main. That's why there is a need to declare their function prototype. So we declare function prototype here. Void A char int float, because A have char int float. So we have to mention in function prototype declaration. Okay class? Void B struct book. Here void B struct book. In function declaration, in function prototype declaration, we do not mention the variable. So variable will not mention, but if there is type, data type, those will be mentioned. Okay, so void B struct book, void B struct book, variable will not be mentioned in the struct in the function prototype declaration. Here is void C struct book asterisk, void C struct book asterisk. Okay class, so function prototype declaration of three functions A, B, C are declared here above the main. Okay class, we define the structure before the main. That's why this becomes the global. Once again, this structure is defined before the main. That's why this structure or you can say this user defined data type, user defined structure data type is visible for all function. For all function here means for function main, for function A, for function B, for function C. So this structure are visible for all functions. Okay, now program execution always start with main. It doesn't matter where main is written in the program. So program execution start from here. Okay, we can write struct book because this struct book is above the main. That's why it is visible for all function. So it can also be visible for this main function. So we can write struct book. This is the data type of this data type. Struct book. This is the data type. P is a variable. This is the data type. This is the variable, and this is the constant. So B initialize structure variable. B initialize a structure variable P. Okay. So first one is a book name. BN means here book name. BP means book page. BPR is a variable which means book price. Okay class, BP is a variable, BPR is also variable, BN is a array, character array. Basically it is a string. Okay, so here book name, book page, book price. So basically these are the variables. So class struct book P. Okay, P is a variable of this structure. So this is visible for all function. So we can use in any function in the program. So in the main we are using struct book. Copy this line. This is the data type. This is the variable of this data type. Okay, and this is the values assigned to this variable. Now class, we are calling the function. We are calling the function A, B, C. So function A, B, C are called here. Okay, A is a function. Okay, P dot Bn. P is a variable. P is a variable of structure. P dot Bn, this will be called P dot Bp, this will be called P dot Bpr, this will be called. So class, in function A, when we are calling function A, structure elements are passing. Class, when B are calling function A, structure elements are passing. You can see P dot Bn, Bn is pass here, Bp is pass here, Bpr is pass here. Here structure elements are passed, not the variable. Okay class? So when here B call the function A, here B call the function A with structure elements, not by variable. Okay? Here function B is called by passing the structure variable, not the structure elements. Here B pass the structure elements. Here B pass the structure variables. This is the structure variables. This is the structure data type. This is the structure elements. Or you can say this is the structure members. Okay class? So function A is called in the main by supplying the structure elements. B is called in the main, function B is called in the main by supplying the structure variables. Function C is called in the main by supplying the address of structure variable. Okay class? This is the return 0 because we apply here int. Here we apply int. That's why we have to write return statement in the last of program. Okay? So class, you can see here function A, B, C are called by passing the structure elements, by passing the structure variables, by passing the address of structure variables. So this is the call by value, this is the call by reference because address is passed here. Here address is passed. This is the call by reference, this is the call by value, and this is the mix of call by value and call by reference. Okay? I am going to describe this there. So class, control start from here, execution start from here, control go to this line, everything is okay. Control go to this line, and this is the function A is called here. Function A is called here. So this main function temporarily suspended and function A will be active. Function A will be active here. Okay, so control comes to here. Here class P dot Bn is supplied. Bn is a name of array. Bn is a name of array. This is the array. Bn is a name of array. So when you pass name of array, base address of array will be supplied. Okay? So here address is supplied. That's why we have to make a variable that is pointer so that it can hold the address. Okay? So we declare here variable s, that is the pointer, and its data type is char because Bn data type is char. That's why we choose here char data type. Okay? Now class, here P dot Bp supplied and P dot Bp here supplied. Bp here is an integer type. That's why we declare variable t that is also integer type. So this P dot Bp is received here. This P dot Bn is received here. Okay? Now P dot Bpr is supplied here. We declare another variable u. U is a float type because Bpr is also float type. And this is a value, not address. Okay? So this value is supplied here. This value is supplied here, and float u is stored this. So class, this is the mix of call by value and call by reference because here you pass the address, here you pass the value, here you pass the value. So this is the mix of call by value and call by address. This is the call by value and this function is called by the address. Okay class? So this one is a call by value, mix of call by value and call by address. Okay class? So here P dot Bn is received here. Here P dot Bp is received here. Here P dot Bpr is received in U. These are the arguments and these are the parameters. These are the actual arguments. These are the formal arguments. Okay class, now you have value, print them. Percent s, this is the format specifier. This percent s, print this s, this percent d, print t, and this percent f, print u. So whatever is supplied here is printed in this function class. And what is supplied here? Let us see is supplied here. 400 is supplied here and 325.50 is supplied here. So these are the received in this variable, in these variables, and we print them. Okay class, so here you can see function A is called function and main function is calling function, because main is calling A, that's why main is calling function, and A is called, that's why A is called function. Okay class, this is the mix of call by value and call by reference, because here address is passed, value is passed, and what you have passed, what you have passed, this is here, address of this and value of this, and this value of this, and this is received in these variables and we print them. Now class, here B is a function and we supply here P, and P is a variable. So class, in function B pass the variable, but in function A pass the elements of structure. Here in function B pass the variable of structure, and in function A pass the elements of structure. Both are different things. Elements of structure are these, variable is this. Both are different things. Here B pass the variable of structure, here B pass the structure elements. Okay, so here B pass P, so everything is passed here directly, and void B struct book, since P is a structure variable and this has data type struct book, that's why we have to make same data type. Okay class, we have to make same data type. Basically P has data type, this is the data type, P is a variable, this is the data type, and P is passed here, so we have to make data type of same type, and M is a variable, so whatever passed in P is received in M. M has data type struct book, P has also data type of struct book. P is an argument, M is a parameter. Okay class, now we print percent s, percent d, percent f, m dot bn, m dot bn, m dot bp, m dot bpr. Okay class, we have now m, in m we have received P, then we can access this from m, m dot bn, m dot bp, m dot bpr. Now class, another things, void C, another function, that is the void C. Okay, here control comes to this line, when control comes to this line, struct P, sorry, m percent P, P is a variable, but here variable of, here address of P is passed here, here address of P is a variable, here address of this variable is passed here. So class, struct book asterisk, this is the asterisk R, so whatever you passed here is received in R. Since here passed the address of P, so we have to make it pointer, so R is a pointer to data structure, pointer to struct book, because class P has data type struct book, this is the variable, this is the data type, P has data type struct book, and P is passed here, so R has also data type, struct book. Okay, here address is passed, that's why we make it R variable pointer, so that it can hold the address of P. So here address of P is received. Now we can print percent s for name, percent d for book page, percent f for book price. Class, there is no dot here, there is an arrow operator, because R is a pointer. when you use pointer in a structure, you have to apply arrow of operator in place of dot operator. So here is a dot. M is a structure variable, R is also a structure variable, but this is the normal variable, this is the pointer variable. In normal variable we use dot operator, but in pointer variable we use arrow operator, this. Okay, here R arrow operator of Bn, here R arrow operator Bp, R arrow operator Bpr. Okay class, so this will be printed. Whatever you supplied is indirectly this will be printed here. So in this program class, you see the combination of structure, function and pointer. Okay, there may be problem in pointers. Later on we will study in detail about pointer. So class, this is the combination of structure, function and pointers. The prototype, function prototype declaration. This is the main function from here to here, and this function A, function B, function C. Okay, all three ABC function are called here. A is called by structure elements, function B is called by structure variables, function C is called by address of structure variables. Okay, ABC is called function, meaning is calling function, because it calling the ABC. Since ABC function are defined after the main, then we must have to declare the function prototype above the main. Okay, and this is the structure which is visible for all functions, because it becomes the global. It declared before the main, so it becomes the global. Class, union and structure both are same, except how union and variable occupy the memory. Void main, union book. In place of struct, you have to use union keyword. In structure we use struct keyword, but in union we use union keyword. So in place of struct book we use union book. Okay, so where you have write the struct in the structure, in union you have to write the union keyword. So union book, this is the union members, or you can say this is the union elements. Okay class, this is the name of union and this is the union keyword. Okay, so this is the new data type. This is the new data type, that is the user defined data type. Okay, and this new data type has variable A and B. So class, this is the name of union, this is the union keyword, these are the union members or union elements, this is the new data type. Copy this line, this is the data type and this is the variable of this data type. So this is the data type, this is the variable A and B, like int A comma B, we use union book A comma B. So union book is a data type like int, and A and B, here int is data type, A and B are variables. Here union book is a data type, A and B are variables, and this data type is like this. Okay class, so there is no difference between structure and union by syntax wise. In place of struct we use union keyword. Okay, and the only difference between structure and union is occupying the memory. How union occupy the memory and how structure occupy the memory, there is a difference. Okay, we will discuss later. First here BC, class. So this is the data type, this is the variable A and B. strcpy a dot name and this is the string. Amit is copy in a dot name. Class, Amit is copy in a dot name. A is a variable of this structure of this union, and a dot name basically this. So Amit is copied in this by strcpy function. Okay, a dot page have value 400. 400 is assigned to a dot page. A is a variable and page is a union member, union element. So here 400 is assigned. A dot price be assigned this. So value is filled in variable A. Okay, now we are going to print name equal to %s a dot name. So a dot name is printed here. So what will be the output? Name equal to Amit. It should be here. Basically name equal to, in place of %s, this will be printed. Again printf page equal to %d a dot page. So 400 should print here. Page equal to %d, in place of %d this should be printed here. So a dot page has 400. A dot page has 400 value. Printf price equal to %s a dot price. So result, what will be the result? Price equal to, in place of %f, this will be printed, and this have value 250.75. Okay class, but result is, the output is here class. For this output is here, output is name equal to, there will be nothing here. Output is page equal to, there is nothing here. Output is price equal to, and this value will be printed here. So that is the 250.75. 250.75. Here there is no value, but here is a value. Class, when this printer print, this will be the result. When this printer print, this will be the result. When this printer print a dot price, this will be the result. Here there is no result, but here is a result. Okay class, this is because of class union occupy the single memory, occupy the single largest memory in all of its member. So it take 4 bytes, it take 2 bytes, it take 30 bytes, because there is a character, and one character, each character occupy the 1 byte. So there are 30 characters, it can hold up to 30 characters, so there are 30 bytes. So this union member occupy 30 bytes, this union member occupy 2 bytes, this union member occupied the 4 bytes, because it is float. So highest memory occupied by any member is this, that is the 30. So union occupy the largest memory block of its member, highest. So here 30 bytes it reserved for this union. Okay, 30 bytes is reserved for this union. So class, when you assign this, when Amit assigned to a dot name, okay, here Amit is stored, but here you assign 400 to a dot page, so overwrite it, 400 overwrite it. So here is 400, but class in the last you have assigned 250.75 to a dot price. So again overwrite. So 400, above the 400, 250.75 is assigned. Now final value will be in this memory is 250.75. That is why this printf print nothing. only this, name equal to this, name equal to this. In place of this there is nothing, because memory is washed that at that in the last. Okay, so page equal to page equal to page equal to, in place of %d there should be a dot page, but there is no page. 400 has washed because there is a single memory, and every member write their value, write its value on that single memory location. So this will be also washed, but this is the last value. A dot price is last value, so this last value is reflected in the memory. That's why it is printed here. That's why it is printed here. So this will be the result. There is nothing, there is nothing, and this is the last value. That's why it is in memory, and printf print that value. Previous value are override. Previous values are overwritten by next value or updated value. Class, there is after this statement there are some more statement here. After this line there are some line here. Here b is another variable. Here is a class, here is a, but here is a b is another variable of this union. So b dot name is Sumit, strcpy copy Sumit into b dot name, printf name equal to %s. Here result will be name equal to Sumit. Okay class, here result will be b just assign the value to union element, and b print that value at that time. So there is no such condition here. Okay, b assign single value and b print them, so it will be printed there. Again, b dot page has value 300 pages are assigned to b dot page, and b print this at that time. So here result will be page equal to, in place of %d this will be printed, and this will be have value 300. Okay class, now b dot price have this. So price is 100.50, and this value is assigned to this price. Printf price equal to here price equal to, in place of %f this value printed, that is 100.50. So class, here you can see all value are printed because we assign the value and print them that time. Here b assigned Sumit to b dot name, and b print Sumit at that time. So there is no overwritten concept here. Okay, in that case there is no overwritten concept. B assign the value, B print that value that time. So there is no problem, all value will be printed here. But here B assign all union members, then B are going to print. In that case only the updated value will be in memory, and printf print only the updated value. Previous value of union are overwritten by next value of union. Okay class, so in short, there is no difference between structure and union, okay, except their memory allocation way, except how they allocate memory to their members. Okay, in place of struct we use union. In structure we use struct, in union we use union. The only difference is that. Okay, so this is the program, all things are same. Class, these are some difference between structure and union. Syntactically, structure and union both are same, except in structure we use struct keyword, in union we use union keyword. Okay, conceptually both are same. There is a single difference. That how structure occupy the memory and how union occupy the memory. In structure, all members occupy the separate memory. That is why we can access all structure elements simultaneously. Here there is no loss of data, okay, but structure occupy the more memory. In case of union, single largest memory is shared by all members of union. In union, the largest space occupied by any union member is shared by all members. Okay, is shared by all members. We cannot access all members of union simultaneously. Okay, here previous value are overwritten by the last value. Suppose there are 3 members in union, all 3 members share the single largest memory location, so the last member, the value updated by last member is persist there. Previous members value are overwritten by the last member. Okay class, it occupy less memory, very less memory in compare to structure.